In this video, we will demonstrate how to calculate for the variable cost, the break-even volume, and the profit in a theoretical hospital that is trying to purchase an equipment. So in this example, we'll use Novacana Hospital, which is planning to invest in a scanner. This hospital estimates that it can bill $2,000 per scan, and the market assessments indicate that demand will be fewer than 5,000 scans per year. The hospital has a choice between the two different types of scans that can fill its imaging needs. Each scanner here has a capacity of 5,000 scans per year, but involves a different mix of labor and capital. So for the first scanner, the total fixed cost is $1 million per year and would yield a profit of $1 million if the hospital produces and bill for 5,000 scans. The other scanner, scanner B, would result in total fixed cost of $2,000 and would yield a profit of $500,000 per year if the hospital produces and bill for 5,000 scans. So we'd like to know the variable cost for each scanner, what are the break-even costs for each scanner, and what are number of scans are the scanners equally where the scanners are equally profitable. And so first step is to calculate the variable cost for each scanner. For scanner A, the formula is that we're using is revenue minus total cost, where revenue is rate times volume, and total cost is your fixed cost plus your total variable cost equals profit. So from the scenario given, we know that each scan would be charged at $2,000 and aiming for 5,000 patients. In this scenario, scanner A, the fixed cost for that is $1 million. And we are computing for variable cost. We also know, so variable cost times 5,000 volume. We also know that the profit here, we assume is $1 million for scanner A. So computing for this, we have 2,000 times 5,000 will give you $10 million minus the $1 million from the fixed cost, and minus 5,000 VC for your total variable cost. That's $1 million. So we have 10 million minus 1 million equals $10 million, minus 5,000 VC equals $1 million. Transposing everything, we have 5,000 VC equals $8 million. And therefore, the variable cost for scanner A is $1,600. For scanner B, we will use the following formula, similar to scanner A. Revenue rate minus total cost equals profit. So here we have the same rate, $2,000 per scan, and volume is 5,000. And total cost is your fixed cost of $2 million plus, again, we're computing for the variable cost times 5,000. Profit here we estimate is only $500,000. So computing for this, 2,000 times 5,000 will give you $10 million minus $2 million for the fixed cost minus 5,000 VC equals 500,000. Right? So computing for this, we'll end up with 5,000 VC equals to $7.5 million. And therefore, the variable cost for scanner B is $1,500. Right? So scanner B has a lower variable cost. Let's compute for the break-even cost. Break-even volume. What's the number of patients that we need to break even? For scanner A, we use the same formula, but this time we set the profit to 0, and we also don't know the volume this time, right? So in this case, 2,000 times V minus $1 million for the fixed cost plus 1,600, which is the computed variable cost for scanner A times V equals 0. So 2,000 V minus $1 million minus 600 V equals 0. And so we'll get 400 V equals $1 million. We therefore calculate the V equals 2,500, which means that the volume here is 2,500 patients. For scanner B, compute for that, exactly the same formula, right? And again, we are setting the profit to 0, and we don't know the volume. Therefore, 2,000 times V minus $2 million for the fixed cost plus 1,500 times V equals 0, or 2,000 V minus 1,500 V is 500 V, and we transpose the million to the other side. Therefore, volume for scanner B equals 4,000, which means that we need to have more patients to break even for scanner B. Right, and lastly, the scenario is asking for us to calculate where a situation where the profit for scanner A equals the profit for scanner B, right? Or as a question is asking, at what number of scans are the scanners equally profitable? So we know that to calculate for profit, it's this formula: rate times volume minus fixed cost plus total variable cost equals the profit for scanner A, right? And similar for scanner B. So at this point, we do not know the volume. We are trying to calculate for the volume where this happens. Scanner A profit equals scanner B profit. But we know that the profit of scanner A in this scenario will equal to the profit of scanner B. Therefore, we can calculate this manner where we set the profit of scanner A equals the profit for scanner B here. So computing for this, for the scanner A side, we have 2,000 V minus $1 million minus 1,600 V. On the scanner B side, we have 2,000 V minus $2 million minus 1,500 V, which gives us 400 V minus $1 million on the left-hand side for scanner A, and 500 V minus $2 million for scanner B. So continuing calculation, we'll end up with 100 V equals $1 million, or the V equals 10,000, which means that once you see 10,000 patients, the profit for scanner A equals the profit for scanner B.